now we are ready for applications of quadratic functions. And so these have a lot of applications. So this is nice to learn. Applications of quadratic functions. Okay, so quadratic. So remember what the word quadratic means. It means the highest power of any variable is 2. So these are the quadratic functions we've been looking at, something of this form. And so recall that the graph of these is a parabola. So if it's facing up, it will have a low point, a minimum, or if it's facing down, it will have a high point, a maximum. And so these are very applicable in everyday life. And so we're going to see a few of these. The first example that we'll look at is about a stone that's thrown off a cliff. It says a stone is thrown directly upward, off a cliff it doesn't say a cliff. Anyway, a stone is thrown directly upward from a height of 30 feet with an initial velocity of 60 feet per second. The height of the stone in feet t seconds after it has been thrown is given by this function. So this function for the first example is s of t is equal to negative 16t squared plus 60t plus 30. And so it says, determine the time at which the stone reaches its maximum height. Determine the time, what is t, when the stone is at its maximum height in feet. So t is in seconds. Let me see, t is in seconds. And s of t, which stands for the height of the stone, is in feet. All right, so if you can draw a picture, it's very helpful. So let's try to draw a picture. A stone is thrown directly upward from a height of 30 feet with an initial velocity of 60 feet per second. So I don't know if somebody's standing, I said cliff, maybe he's on some kind of cliff. So here's some person, and they've got this stone, and so they throw it up, and it goes up, and it comes back down. Okay, so so here he is, he throws a stone, it goes up and it comes down. And I drew it in a parabola shape because I looked at this function, and this is a quadratic function, and it makes the graph of a parabola. So this right here is the maximum height right there. That's its height. Okay, so this is the maximum height that occurs at the vertex. So V is HK, right? That's our vertex. Okay, does it make sense that it's facing down? It does, because A is negative, and that's what they do. So the question we have to answer is determine the time at which the stone reaches its maximum height and find the maximum height. Well, in this particular problem, h is the independent variable, so this is the time. This is t, and I'm going to say t max because it's the time it takes for it to hit the maximum, and s of t is the k, and this is the maximum height. Okay, so this is what we're interested in. This is our h and this is our k. If we can figure out what those coordinates are, we can answer these questions. H, if you'll recall, this is not in vertex form, but we can figure it out by saying h is equal to negative b over 2a. What is b in this case? It's 60, so we'll say negative 60 over 2 times a. What is a in this case? It's negative 16. So I'll get my calculator out, and I'll say negative 60 divided by negative 16 will give me positive, okay? So if I take 60 divided by 2 times 16, I get 1.875. So this is what this guy is. 1.875 seconds. Okay, how can I figure out K? Well, I can plug in H. In general, K is equal to F of H. So our K, or our maximum height, right, the max height, which is what our K is equal to F of 1.875. So I'm going to plug that into this function. I'm saying F, but it's really the S function. So it's negative 16 times 1.875 squared plus 60 times 1.875 plus 30. All right, so I'm going to plug this stuff in. I'm going to say this squared times negative 16. I have that much, and it's negative 56.25. I'm going to say plus, parentheses, 60 times 1.875. And then if I add those two things together, I get 56.25 plus 30. I get 86.25. And that is what K is. The max height is 86.25 feet. So let's write a sentence. All right, let's say the stone will reach its maximum height of 86.25 feet after 1.875 seconds. All right, that's our first example. Let's do our second one. It's very similar. So now that we've talked through the steps, this one shouldn't take that long. The second one is the height of a rocket. So it's not a rock, it's a rocket, but that's okay. They give us a formula. It says, a model rocket is launched with an initial velocity of 100 feet per second from the top of a hill that is 20 feet high. Its height in feet, t seconds after it has been launched, is given by this function. Determine the time at which the rocket reaches its maximum height and find the maximum height. It's very similar to the last one, only it's a rocket instead of a rock. That is fine. So this is number 2. And it goes like this. It says that the height is given by s of t is equal to negative 16 t squared plus 100 t plus 20. You might notice this negative 16 keeps showing up. That is the gravity force pulling down on the rocket or the rock. Okay, so if we have to figure this out, you might say, oh, this is a quadratic equation. What does it look like? It's going to look like this. So let's see. It's launched from where? From a height 20 feet high. So I don't know. It's on some kind of stand. Let's say it's on some kind of stand that's 20 feet off the ground, right? This is 20 feet high. Okay. And so then our rocket is launched. It goes up and it comes down, and it has a similar look to this other guy because it's got a negative a value. And so this is the vertex. So if we can figure out the h and the k, we can answer the question, because h is going to be t. This is going to be t max, and k is going to be s of t max, or that maximum height. So what is h? H is negative b over 2a, or negative 100 in this case over 2 times negative 16. H is going to be a negative divided by a negative is a positive. 100 divided by 32 gives me 3.125. The units on this are seconds. So the maximum, the time it takes for this rocket to reach its maximum height is 3.125 seconds. What is the maximum height? Well, in general, k is equal to f of h. So the maximum height, the k value of the vertex, is going to be when you plug in that h value. So what is s, which is our function name, of 3.125? Let's see, that's going to be negative 16 times 3.125 squared plus 100 times 3.125 plus 20. So let's see how this goes. If I square that times negative 16 plus 100 times 3.125 plus 20 gives me 176.25 feet. Okay, can we write a sentence? Yes, we can. The rocket, the toy rocket, reaches its maximum height. Whoops, can I spell though? Height of 176.25 feet after 3.125 seconds. Okay, so there are a couple of examples of applications. Here is one that's just a little bit different. Let's look at number 3. And it has to do with a parallelogram, okay? So let's see what we could do here. It says, the sum of the base and the height of a parallelogram is 69 centimeters. Find the dimensions for which the area is maximum. So let's just see how we can approach this guy. This is very different. They don't just come out and hand you a formula, you gotta kind of work for it. So let's see what we can do here. Sometimes they'll have you do that. A parallelogram, let's think about that. That is a 4-sided figure, and the sides that are opposite from each other are equal in length, and they're also parallel. So here is a generic parallelogram. All right, this is a parallelogram. Okay, so right here. So like these would be the same length, and these would be the same length, okay? And the area of a parallelogram is the same as it would be for any figure. It's base times height or length times width. So, but the height is not this. This is the height right here. This would be like a perpendicular that you pass down. That would be the height right there that you would have to figure that out. So, but this right here is the base or the length. So length times width or base times height. So let's see, did they give us any other information? They said the sum of the base and the height of a parallelogram is 69. So that helps. So we're calling this the base and this the height. So maybe just let me give a different color so it doesn't look like that's the same thing. So we don't know the height. Let me do the height this way. This is the height. Some perpendicular that's dropped down. So the area is base times height. They gave us this other information that said if you add the base plus the height, those length, it's 69. So it's the base plus the height is 69. Okay. They said, what dimensions do we have to use? What base and what height length will give us a maximum area? So this time we have to work on figuring things out. Now, if you don't like working with B and H, you can call these whatever you want. I guess I'm going to call them, instead of B and H, I might just call this X and Y because X and Y just seem easier. I'm going to call my height Y and the length of this X. So the area is going to be X times Y. And so X plus Y is 69. Okay. So what can I do with this? Well, I want to maximize the area, so I definitely need this equation. But what I'm going to do, instead of having to work with two different variables, X and Y, I'm going to solve for one in terms of the other by using substitution. So what I'm going to do is I'm going to solve for Y, and I'll get Y by itself by subtracting X. So if I do that, I subtract X and subtract X, I'll get Y is equal to 69 minus X. Now, why is that helpful? Well, because now I can substitute this expression in for Y and get that area is equal to X times 69 minus X. So let's distribute that X. We get 69X minus X squared. And if I want to rearrange the terms, I get negative X squared plus 69X. Now, what's familiar to me about this is that this is the equation of it's a quadratic equation. This is the equation of a parabola that's facing down. Do you see that negative? So it's this kind of a parabola. And the maximum of whatever, and this is area, and I want the maximum area, will occur at these coordinates. So this H and this K, whatever this is, this H would be the value of X that I need in order to make this maximum area, and the maximum area would be K. All right, well, how can I figure that out? Well, H is equal to negative B over 2A, right? So this is going to be negative 69 over 2 times negative 1. So 69 divided by 2, whatever that is, 69 divided by 2, oops, that's not the right screen. 69 69 divided by 2 gives me 34.5. H is 34.5. What is that? That is the value that X needs to be. So X needs to be 34.5. And then this will give me the maximum area if I plug in 34.5. So what's the maximum area if I plug that in? The maximum area is going to be negative 34.5 squared plus 69 times 34.5. Let's see what that's going to give me. 34.5 squared times negative 1 gives me negative 1190.25. Now I'm going to add 69 times 34.5 and I will get, oh, the maximum area is going to be 1190.25 square. What units am I in here? Square centimeters. Centimeters square. Okay. But is that what they asked me? Did they say, what is the maximum area? I don't even think they did. It just said find the dimensions for which the area is a maximum. Oh, what is X and what is Y? That's what they want to know. The dimensions, X and Y. Okay. So let's figure that out. What would Y have to be? Well, let's see. Here's a formula that relates X and Y, and we know what X is, 34.5. So let's just plug that in. Let's plug that in right there. So we'll say 34.5 plus Y is 69. So we'll subtract 34.5 from both sides. And we'll get that Y is equal to 69 minus 34.5, which is 34.5 centimeters. So it turns out that the dimensions that will give us a maximum area for a parallelogram will be when the length and the width are equal to each other, and they when X and Y are the same length, like in a square. Okay, so that is that one. Let's look at one more example and then we'll be done. It has to do with profit. So the profit is the money that you get to keep after you've paid your bills. The revenue is the amount of money that you get that you have coming in, but that's not the amount that you get to keep because there's always a cost to running a business. So the revenue is all the money that you get coming in after you make a sale, but then after that you have to pay your bills, called the cost. And then what's left of that is called the profit. So sometimes they'll give you a revenue equation and a cost equation, and you have to subtract those to get the profit. So in general, here you go. Profit is equal to revenue, all of the money coming in, the revenue minus the cost of running your business. Okay, so there's a couple of questions on there. Let's look at the one about, it says, well, let's give something that's got some kind of, I had one that I liked. Here is one called, it's about a bicycle design. No. Here is one about, it doesn't even give us what it sells, but it just says this. The profit of a company in dollars is the difference, the subtraction, between the revenue and the cost. It just said what I just said right there. So in function language, this might look like this. You'll have some profit function. P of X is equal to R of X minus C of X. Profit is revenue minus cost. Okay, and so they give us an equation for the revenue. They'll say they want us to find the maximum profit for this company, and they say R of X is equal to 810X minus X squared, where X is the number of units produced, okay, it's the number of units produced for this company, whatever they're producing. And then C of X, the cost of producing X units, is equal to 2,000 plus 70X. Okay. So they give us a revenue equation and a cost equation, and we have to come up with the profit equation, and we can do that. Let's do this. Profit, P of X, is equal to revenue, so just write that down. 810X minus X squared. Profit minus, put parentheses here, because we're going to subtract the entire cost. 2,000 plus 70X. And so now we're about to come up with our profit equation. In general, when there is a positive 1 in front of a parentheses, you don't actually need the parentheses. So I can just erase this if I want to, without it messing anything up. When there's a negative in front of it, that's a -1. And it must be distributed. So if there's anything besides a positive 1, it has to be distributed. So negative times 2,000 is -2,000. And negative times 70 is -70. So now the profit, I have to combine like terms. I have -x squared, okay, minus 70x plus 810. So 810, oh, come on now. 810 minus 70 is 740, so we'll say plus 740x minus 2,000. This is my profit equation. I want to know how many units, what should X be I need to sell in order to maximize my profit, and what will my maximum profit be. So in order to find that out, look at this is a parabola. This is facing upside down. This is the maximum that occurs at HK. If I can figure out what H is, well, H is -b over 2a. So H is -740 over 2 times -1. Negative over negative is positive. 740 divided by 2 is 370. Okay, so I need to sell 370 units of whatever it is I'm making in order to maximize my profit. What will the maximum profit be? Plug in H to get K. P of 370 will be -370 squared plus 740 times 370 minus 2,000 gives me, let's see what it's going to be. Let's square that. Plus 740 minus 2,000 gives me 134,900. Let's write a sentence. In order to maximize the profit, in order to, let me rewrite this, obtain a maximum profit, obtain a maximum profit of how much? $134,900. How many units must we sell? 370 items or units should be sold or produced and sold. All right, so there's a sentence we could write about that. Okay, so that's some examples of quadratic application.